Let's discuss estimation of a population mean. How can you estimate the population mean? Sample survey extract only one set of a sample from a population. Population can be 10 million, 100 million. We collect one sample such as 1,000 sample only. Sample mean, we consider it is estimate of the population mean. Is it good estimator? Just only one sample? We already discussed this issue when we explained the sampling distribution of all possible sample mean. Remember, if a sample size is large enough, okay, large means even if you have 100 million, so the sample size is 1,000, then the distribution of all possible sample mean is normal by the central limit theorem, and the variance of that normal distribution is population variance divided by sample size. Therefore, it is very skinny distribution around the population mean, and any sample, if you select from all possible sample mean, you practically one sample, but it can estimate population mean reasonably well. That's the theory. Well, even some worst case, well, there is some error, but it's not much. Let's remind you this example. We don't know the population. I assumed the three kind of population. Normal is exponential, and then uniform like this. I collect some sample. There are 10,000 population data. I collect 5 sample size, 10 sample size, and 100 sample size. I mean, I collect roughly, let's say, 100 samples. Not all possible sample. If I collect 100 sample and calculate the sample mean, their distribution look like this. Okay. It is not skinny yet, but if you increase 100, all the possible sample mean distribution look like a very skinny. Any of these sample mean can predict population mean well. Not only the normal population, even if the population is exponential, it is very skewed distribution. In case of sample size 100, it is close to population mean, look like a skinny normal distribution. But this is example of uniform. If you increase the sample size this amount, if here's a population mean, it is a normal distribution like this. That's the theory of estimation. We cannot calculate all possible sample mean, just a single sample, single set of sample. But we know this kind of sampling distribution, and it is reasonable to estimate any of these value can estimate the population mean. There's some terminology. If you collect a sample, you calculate a sample mean and estimate population mean, then we call this is point estimation. In case of a sample mean, it is scattered around the population mean. Their mean is also population mean. We call this is unbiased estimator. If a sample size it keep growing, the distribution, sampling distribution become skinny, more narrower. Well, if n is very large, it is nearly close to population mean. We are saying it is a consistent estimator. Sample mean satisfy this property? Well, it is a little advanced topic. If there are many unbiased estimator, and among that, it is the smallest variance, we call this is effective estimator. Sample mean also satisfy that. It means sample mean satisfy all the criteria of a good estimator. That's a point estimation. Sample mean is good as a point estimator. Interval estimation. Well, we estimate population mean using interval. What kind of interval? You calculate sample mean. Assume temporarily we know population standard deviation, then x bar plus minus some kind of z value, and sigma over root n is a standard deviation of sampling distribution. We call this is standard error. Well, for example, 95% confidence interval, we are using this formula. Do you remember this value? In case of normal 0, 1, the center 95% is mean plus minus 1.96 sigma. We have a normal distribution which has mean mu, and standard deviation is sigma over square root n. It is similar that formula. The derivation, well, I explained in your textbook. Why don't you refer that? This is 95% confidence interval. In case of 99% confidence interval, we are using 2.575. It's a center 99%. That's the formula. What's the interpretation? If you apply 95% confidence interval to all possible sample mean, this is not all possible sample mean. This is population. Mean is here. This is normal 0, 1 population. It's 10,000 data. Mean is around 0. If you apply x bar, in each sample x bar plus minus 1.96 sigma over square root n, then I applied for 100 sample. Okay, it's a simulation. Among that, in this case, 96 of them include population mean. That's the meaning of a 95% confidence interval. That means there's a possibility 5% the interval you calculate might not include the population mean. Since we collect a small sample compared with the population mean, that kind of mistake you should accept that. That's the interval estimation. Suppose you have a sample of 100 college students. The starting salary is 275. Unit is some Korean won. Then what is the estimate of average starting salary? It's a point estimation. It's simply population mean is 275. What is 95% confidence interval? 99%? Well, let's look at what is the answer. This is the formula. In case of 95%, this z value corresponding to normal distribution centered 95%. Therefore, you applied 1.96. Sample mean is 275. Sigma, you assumed 5 in this case, divided by the square root 100, therefore 10, you will have this kind of interval. 99%, you switch 1.96 with 2.575. Well, as far as calculation concerned, maybe just plug in numbers. Here's one question. If a sample size is 400, what's the change? Okay. In case of 95%, If sample size is changed, if it is increased, maybe this value, sample size is increased, means this value is smaller. That means it has a more skinny normal distribution. Therefore, interval size will be small. Okay. One more thing is, compare this 95% and 99%. We call this is some kind of confidence level. How much you are sure. I mean, how much mistake you allow. If you compare two intervals, which one is wider? Definitely, since you are using this value 2.575, this interval is wider than 95%. Well, but assuming population standard deviation is unrealistic. Because of that, we might need to use sample standard deviation. If you don't know population variance, practically we don't know that. You are using similar formula with a sample standard deviation instead of a population standard deviation. But theory shows that instead of Z distribution, standard normal, you have to use T with n-1. What is T distribution? It was developed by the statistician Gosset in Ireland. Look at this. This red one is normal 0, 1. The blue one is the T distribution. If you compare two, this is T3. T can be any number, T1, T2, T3, etc. This is a comparison of T3 and the normal. The T3 is a little more, it is flatter than standard normal. Therefore, if you have a small sample size, you have to use this T. But fortunately, if a sample size is large, let's say 50, 100, this T distribution is very close to standard normal, then you can use a similar formula with the previous one. Let's practice an example. In the previous example, suppose you know sample standard deviation. What's the change? We are talking, you need to look up T25 minus 1 distribution, T24, and then the center point. Therefore, the corner point is 2.5. You have to look up this value. That's this one. Remember, it was 1.96 in case of a normal, standard normal. It is a little wider distribution than standard normal. You are using similarly this kind of formula. Okay. Just switch Z value with the corresponding T distribution, Tn-1 distribution, and some value related with the both side corner. In case of 95%, 2.5% each. Therefore, you have to look up this table. Okay. T distribution 0.025. Well, it is a nuisance, but you can practice using instead U. Okay, let's do estimation using this number. Let's copy this number. Let's go to instead U. There are some menu instead U confidence interval. Here's the estimation. You can copy some numbers here. They automatically calculate this value. Depending whether you know sigma or not, default is, we don't know the population standard deviation practically, then you have to use sample variance, sample standard deviation, and then you have to use a T distribution. In this case, you have a 10 data, therefore you have to use a T9. Okay. Well, they already calculated confidence interval. If you execute the button, they're gonna show you confidence interval. What is this interval? You can practice that. If you increase the sample size, the confidence interval become narrower. Well, if you have a smaller sample size, well, it will be larger. How about if you increase confidence level lower than 95, it becomes narrower. It is some kind of a simulation experiment. I hope you understand this theory and practice. It is used so a lot. Okay, see you on next